Okay. Ludovic is going to tell us about Guix, which is for geeks or for people too?
For geeks. Okay, so here we go. So hello, my name is Ludovic, and so I'm the co-maintainer of Guix, together with Andy Ringo, which you've probably met, most of you, I guess. And so Guix is a scheme implementation, and it's great. And I'm also a contributor to NixOS. So how many of you have heard about NixOS? That's quite a lot. So basically, the idea of this talk is to get these two popular projects and to marry them somehow. Okay, so what's Guix? So Guix is a new thing. It's pronounced Guix, like Guix and not Guix and Guix. Okay, that's very important. And it's a functional package manager. And it's written in Scheme with Guix, and it's a new programming layer for Nix. So what's Nix? So Nix is a functional package manager. So you may say functional, what do you mean by functional? Okay, so yeah, of course, other package managers like apt, dpkg work too, so that's not what I mean by functional, but I'm going to get back to this later. And yeah, so NixOS, but most of you already know it, so it's a free GNU Linux distribution which was started around 2006 or a bit earlier. So initially it was more of a research project and an experiment, but now it's a community project with a whole lot of contributors and many packages and nice features. So I'm going to basically present what Nix and NixOS offer, because Guix is more or less using the same ideas. So here we go. So basically Nix provides many features which are not commonly available. So from the user point of view, suppose you want to install two packages in a row, like you want to install GC 4.5 and iSCAT, so you can do it as a normal user. You don't need sudo or you don't need to be root. And you can have one user which installs, say, GC 4.5, and another user on the same machine which installs a different version, and it just works. So you may say many machines are single users nowadays, but okay. Now if you look at the dependencies of what this person installed, you see it's using such version of glibc, such version of GTK+, blah, blah, blah. Whereas this user on the same machine has a different version of glibc, a different version of GTK+, and so on, and it just works. And so I mentioned transparent binary source deployment. So what happens basically if you're lucky, when you want to install something, it will just say these packages are going to be downloaded, and it just downloads them and packs them and you're done. But sometimes, for instance, if you've modified the packages, or if for some reason there is no pre-built binary available, then you may end up with something like this saying, okay, these dependencies are available as pre-built binaries, so they will be downloaded, whereas these ones need to be built. Okay, so it transparently uses either pre-built binaries available on a remote site, for instance, or it actually builds the software, so it's transparent. Okay, transactional upgrades and rollback. So that's another nice feature. So basically, if you want to upgrade your user environment, so all the packages which are visible to you, so with Nix you can use this command, nixenv --upgrade* to upgrade everything, and so it will upgrade all the packages that you have. And if everything goes well, then it's a transaction, so everything is upgraded, and you can just notice that you actually get the new versions that you wanted. But if something goes wrong, like you unplug your computer right in the middle of the upgrade, well, that's no problem. It still works, so you have the previous versions available, and it's not broken. So try to do this with a regular distro, and basically the system is likely to be screwed. So that's the idea. So you can do rollback too. So suppose you upgrade GIMP because you want the latest and greatest. So you have version 268, which is no longer the latest. And you're happy, you upgrade it to the new version, and the new version basically doesn't work. So you're not so happy. Okay, so you could go ahead and debug GIMP. That's one solution. The other one is just to roll back and you just get back to the previous generation instantly and you get back to your previous GIMP version, which actually works. So that's pretty cool. Okay, so what NixOS provides too is whole system descriptions and instantiations.
We couldn't read the previous slide.
Oh yeah, so why? Yeah, so that's just the outline, so yes.
Can you tag known configurations and then roll back later? So I've observed when I use Debian sometimes that I need to install a package from testing.
Yeah.
And it pulls in a bunch of dependencies, and then a month later I realize that some other program has broken. And then trying to figure out how to roll everything back to get to the state where
it actually worked.
It also worked is very difficult and time consuming.
Yeah, so actually Nix numbers each generation of your environment. You cannot currently add a tag to say this number is called versions that works.
Does it really tell me when the versions were created or the generation was created? So the timestamp was associated?
Yeah, there's a timestamp, yeah. So that gives a hint, typically.
And if I roll back, can I easily roll forward again?
Sorry?
If I roll back, can I easily roll forward? So say I roll back, then can I say roll forward to generation 287 later?
Yeah, you can switch between any generation number, so that's the idea.
Is it able to manage? What happened with configuration files?
So
when you or configuration directories where you can add new files, for example.
So you mean per user configuration files like .gimp?
For example, when you use .gimp and then you install some foo scripts for the new version.
Script foo stuff. I mean, yeah, so it doesn't handle it. So the short answer is if you have per user configuration file like a .gimpRC, whatever, it doesn't handle it. So it's still your job to actually manage your configuration file and upgrade it. So yeah, that can be annoying, but yeah, Nix doesn't handle it.
In the configuration of the server, for example, you create the lab server and you roll back. It's rolling back to your old configuration, or you must manage?
No. So per user configuration files are Nix doesn't touch it, so it's your job. Yeah. Okay, so now the cool thing is that with NixOS you get a single configuration file which is global and describes basically all the system configuration. So you have things like you say which version of the kernel you want to use, which modules, for instance, how you want to build your initrd, what parameters you want to provide for grub, which file systems are mounted, what swap you used, networking settings, setuid programs, blah blah blah, users. So everything is, you can put it in a single file and it describes the whole system configuration. So the cool thing with this, you can also describe services, like if you want to start an SSH daemon, if you want to start Everheater, blah blah blah, you can all describe it here. And the cool thing is, once you have this description, you can actually do the same thing as with user environments. So you can do transactional upgrades to a new system configuration, and you can do rollback and everything. So if you do NixOS rebuild switch, well, it will switch to the new version with the new configuration, right? And if you do build VM, what does it do? It actually creates a QEMU image which you can run to test your machine before actually switching to the new generation. So you get a script which you can run to try your new configuration, and if you start it, you get a VM where you can just make sure that things actually work, at least in the VM. And then if you're satisfied with what you got in the VM, you can try test, and it will activate the configuration right now. So if you have like new services enabled or new versions, it will start them. And finally, when you're really happy and you want it to be the default at boot time, then you can say switch, and it will add an entry to the grub menu. So next time you boot, you have an additional entry in the grub menu saying this is the new generation, configuration 37, and that's it. So if it turns out to not work as expected, you can still boot in a previous configuration. So that's the idea. And of course you can use Nix switch dash dash rollback if there's any problem. And voila. So you're already convinced, I guess, and you want to know more. So maybe it's time for a break. So if you have any question or doubts or anything. Yeah.
The packages that you install are these the pristine source packages, or have they been tuned in a particular way? That is 5% of the package already configured for something, or is it pristine clean?
So it's mostly a problem of the distribution itself, right? It's not directly connected to how Nix and NixOS work. But basically, most of the time, it's pristine packages, yeah. So, yeah, I tell more about it later, but usually it's pristine.
But if I wanted to have my SuperDuper package distributed with Nix, I don't have to modify it at all. I can just take the table and...
Yeah, right, yeah. So, I mean, adding a package to the Nix distribution, which is actually called NixPKG. So NixPKG is a subset of NixOS, so to speak. So it's a collection of packages, and if you want to add your package to this distribution, it's just like adding a package in Debian or anything else, right?
Yeah, but so with Debian, it has to be there has to be a lot of well, I wouldn't say a lot, but there has to be. There is a particular effort that has to be required to...
yeah, so you need to provide a build recipe and stuff like that. I'm going to describe it afterwards. Yeah.
Okay. Right.
So how does the system deal with, I guess, conflicting requirements on system-wide services, like if I have Apache or SSH?
Yeah.
I have two users run an SSH service on port 22. I have version dependencies on my Apache that I'm running for my PHP script, which I might need in user mode, but it has this impact on this Apache on port 80. How do you deal with that?
So for whole system services, which basically all the services which are started when you boot your computer and which needs special privileges, special ports, and etc. So you can basically do all the checks that you need at rebuild time. So when you type NixOS rebuild, there are several checks that can be made statically before you actually build the new configuration.
I'm not necessarily talking about something that has a privilege. It's a privilege. Like if I run a MySQL server, right?
Yes.
I can have somebody wants MySQL 5.5 and somebody else wants 5.1.
You mean as a user or as a system-wide service? Or?
I can run Postgres or MySQL as a normal user. I don't need special privileges.
So if it's as a...
Two users have different version requirements there.
Yeah, well, it works. You want to know how it works? I'm going to detail it. That's what you're asking. Okay, I'm going to go into the details. Yeah. Okay, so I just continue. So now I'll tell a bit more about how it actually works, because I was just showing off with all the features, and now let's see how it works. So build environments. So Nix started based on the idea that it's actually very hard to have reproducible build environments. So what defines a build environment? So there are several things, like when you're building some package, what matters is which versions of the dependencies are being used, which compiler is being used, what compilation options you used, and there are several other things which could matter, like what local you're using, what time zone you're in. Sometimes it can interfere with the build process in some weird way, and even which paths are being used, like is your compiler under user bin GCC or user bin GCC -4.5. So, and then there are a number of options, so you have to give -i flags, -l flags to the compiler and linkers. There are environment variables all around, many of them, and all this can interfere in weird ways. So it's actually very hard to control all of this, and it can lead to build environments which are hard to reproduce. Like you have some user saying, oh, I can build your software on my machine, and you say, well, that's weird, we have the same versions and everything, and it works for me. But yeah, there are so many things to check if you want to make sure the environment is really the same, that yeah, it's actually pretty hard. So Nix tries to address this. So it has several tricks to really control the build environment. So first, each package is installed in its own directory. So think of it like GNU store, for instance, is more or less the same idea, but in a more formal way. And then once a package is installed, it's immutable. So you're never going to modify any package once it's installed, right? And if you have, you cannot have a build process with undeclared dependencies. Like if you have some package which needs Perl, it really needs to have a configure script, for instance, which actually checks that Perl is available, something like that. Because if you don't explicitly specify this build process needs Perl, then it won't have it. That's the idea. So that's principle of least authority. So to achieve this, the build itself is performed in a CH root, typically, where only the actual declared dependencies are available. So if you said this build process needs gcc, GNU make, bash, core utils, and that's it, then it will only have it in the CH root. So it cannot use Perl if you didn't explicitly say, I need Perl in this build process. And on GNU Linux, it also uses separate UIDs and PID namespaces with this Linux feature. So that's the idea. So there's a special directory called /nix/store. So we call it the Nix store, typically. And in that directory, you have one directory for each package that you built. So you have, say, one directory for libc, lsh, GNU-TLS, Emacs, and all their subdirectories in there. So that's the idea. And you have a weird hash there, which basically identifies all the inputs to the build process. So each time you switch, you flip a bit in some of the inputs of the build process, you basically get a different hash. So if you build two different variants of libc, for instance, you will get two different hashes. So two different variants could mean that you're using a different compiler, or you're setting different environment variables, or I don't know, changing something in the build script, whatever. Yes?
Do you virtualize time?
No. So that's the problem, because I think at some point GNU-LD would add a timestamp by default to builds, so you would get non-deterministic build results. But I think it's now switched off by default, something like that. But still, if your build process uses time in a weird way, of course you can get weird stuff. Yeah. So now, since you have all these packages in different directories, you need a way to actually get the union of all these things. So the way it's done is using symlinks. So from the user point of view, what you have is just a symlink forest which points to all these packages. So suppose you have version 42 which points to an environment containing OpenSSH such version and such version of iSCAT. Then you want to upgrade OpenSSH. So first of all, a new environment is created with symlinks pointing to the new version of OpenSSH, right? And yeah, so that's the actual environment with pointers to the SSH and iSCAT binaries. And once this is done, atomically you get a new generation of your user environment pointing to this new symlink forest. Okay, so atomically you get well, the new set of packages. That's it. And you can, yes?
What's the prefix that you build with? So when you build a package, you use -- prefix equals whatever.
Yeah, so -- prefix equals to /nix/store /this hash. So
what does that hash generate over?
So
the binaries, because you don't know what the binaries are before you.
So roughly the hash is generated over all the inputs to the build process. So dependencies, build scripts, variables, stuff. Okay, and of course you can remove previous generations if you no longer need them. And eventually you can even run the garbage collector, and if some paths are no longer referenced from anywhere in the system, then they get removed. So that's just like a regular garbage collector thing, but applied to the file system. Okay, so store path. So suppose you want to execute the build process to actually build the Guile package, the Guile binary. So you would type this command, and you would get this path with this hash, which, as I said before, is basically the hash of all the dependencies on build scripts and stuff. So you can query all the prerequisites of a given path, so all the dependencies, and the system knows that this particular binary depends on all these paths, so libc, libunistring, blah blah blah. And since the system has all the information about the dependencies, you can even copy the whole closure, so the package itself and all its dependencies to a different machine, and it will just copy all the paths which are actually needed on the remote site. So that's pretty convenient. And so we end up with a complete dependency specification. So if you look at, we can see image. So this is actually, imagine a dense DAG. Okay, so this is GNU Hello. So GNU Hello is actually at the bottom of the DAG, right? And this is all the dependencies needed to actually build it. So you would think that GNU Hello has few dependencies, but actually, when you think about it, it needs gcc, glibc, make, which itself needs another gcc, libc, etc. So with Nix, you get a complete specification of the dependencies down to the compiler's compiler itself. Okay, so for instance, you're using some GCC, but it itself had to be compiled from another compiler, right? So in Nix, you're obliged to provide all the specification. You cannot just get, some compiler out of the blue. So in the end, it boils down. So for bootstrapping purposes, there's a very small set of pre-built binaries at the very beginning, which is then used to build, the first libc, the first GCC, blah, blah, blah. And the whole system is bootstrapped this way. So you get the source for all the distro. Now if you look at just the runtime dependencies of GNU Hello, of course it's much simpler. It's just this very simple DAG. You just have Hello depends on libc, which depends on the Linux headers. And the funny thing is that these dependencies, these runtime dependencies are automatically inferred by conservative scanning. Okay, so what Nix does is that when you're done building a package, it will just scan all the files recursively in this package, in this binary, and it will look for path and